Hello guys, welcome on Tesla Adventures. Today in this video, we are going to discuss the projectile motion from the top of a building or a tower. So let us discuss the case one in which we have projected a ball in the horizontal direction with some velocity u from a top of a building of height h, and we need to find out its time of flight and range. Obviously, maximum height attained is itself h, and it is not going above this point, and therefore we need to find out just the range and time of flight. So you can see, first of all, the thing which we need to discuss is the fact that some students are very confused in the trajectory of this projectile motion, which means that they are drawing this trajectory like that, which means that they are making this projectile strike the ground at 90-degree angle, which means that we are assuming that the x velocity of the projectile at the time it would strike the ground is 0. So this is not possible because we are not assuming any air resistance or any other force which is acting in the horizontal direction. Therefore, we can say that the x component of the velocity of this projectile would always remain the same, and u it is. And at the time it would strike the ground, it would strike at some angle alpha, because this velocity will still remain u and this will be v by. So we know that the initial velocity in y direction is 0. Therefore, this is the case of dropping a stone. Now the time of flight would be under root of 2h by g. This is the time of flight in the case of dropping. So the time of flight would be under root of 2h by g, and the range would be equal to the product of x component of velocity with the time of flight. So the range would be equal to u into under root of 2h by g. This is the range of projectile in this motion. Now you can see that let us discuss the second case, in which in this case you can see that we have projected 3 different projectiles at the same time with same speed u, but in 3 different directions. So we can say that the fastest projectile which would be reaching on the ground would be 3, and the time taken by 3 is least to reach the ground. So time of flight of 3 is least, and then time of flight of 2, and then time of flight of 1. Which means that the projectile 1 would take the greatest time to reach the ground. So this is the fact. And the other fact, which is very interesting fact, is the fact that all these 3 projectiles would reach the ground with the same speed, because we can say that the initial kinetic energy of all of them was mu square, and work done by gravity on all of them is mgh, because this height is h and mg is acting in the downward direction. And the kinetic energy with which they would reach the ground is k final, and it would be equal to the initial kinetic energy plus work done by gravity, which is mgh. So if you are assuming that if their m is not same, then what? Then you can see that when you will substitute the value of final kinetic energy like that, then m is cancelled out, and this fact that v final is not depending on the value of mass. So v final will be u square plus 2gh root. This is the v final. So it is not depending on the mass, and u of all of them is same. Therefore this speed would be same. But I know that what are you thinking, that they would all strike at some different angles. Yes, I am also agreed with the fact that they all will strike at some different angle. So what we can do is the fact that you can also check that. Let us suppose we are talking about this one. this angle is theta. So this component of velocity is u cos theta, and at the time it would strike the ground like that, then the x component would be u cos theta itself, because it would always remain constant. And the y component of velocity vy can be calculated by the third equation of motion. Vy square is equal to u square sine square theta, which is the initial velocity in the y direction, and minus, in fact plus, because displacement h is also measured in the downward direction and g is also acting in the downward direction, so plus 2gh. So vy will be equal to under root of, or vy square is this one. So now the v, final velocity with which they are reaching the ground, v will be under root of vy square plus u square cos square theta. So you can see that it is equal to u square plus 2gh, because u square cos square theta plus u square sin square theta is u square. So again we are getting this result, which is the fact that this speed with which they are reaching the ground will be same, and it is not dependent on the projection velocity. In fact, it is not dependent on the projection angle. But obviously you can see that the angle at which they will strike the ground would be different for all of them, and therefore we can say that this object, these three objects would strike the ground at different velocities, but their angles at which they are striking the ground would remain same. In fact, different velocities, but speed of each of them would remain same. Now in this case, in which we are projecting this projectile at some angle of theta from the horizontal, we need to find out the range and the time of flight. So let us suppose that this is the range, and to calculate the time of flight we know that ux is equal to u cos theta and uy is equal to u sin theta. Now in y direction we can apply the equations of motion. So in y direction you can see that the final displacement would be minus h, because this particle has descended down in the y direction by a distance of h, so the displacement would be minus h, and uy will be u sin theta. In fact, let me write it down as uy only, and the time of flight is t, and minus half gt square. So you can see that gt square minus 2uyt and minus 2h is equal to 0. This is the quadratic equation, and the time would be plus 2uy plus minus under root of 4uy square plus 8gh by 2g. Now you can see that this term is obviously greater than this term, therefore we cannot take this negative sign, because in that case time would be negative and negative time cannot be taken. So obviously time is equal to 2uy plus under root of, now let us do one thing, that let us take 2 common and let us cancel this 2 with this one and 2 common from here. So it would be uy plus under root of uy square plus 4gh divided by g. This is the time of flight, and if we will multiply this time of flight with the horizontal velocity, then range would be equal to u cos theta into this time of flight. Or some students say that what if we find out the time from this point to this point, and then we will add this the time of this point to this point with the time of this point to this point. So they are calculating the total time of flight in 2 parts. In the first part they are writing the time of flight equation for this time, and in the second part they are using equation of motion to find out the time of flight from this point to this point, and finally they are adding these 2 times. Then also you would be getting the same result. So if you are applying the equation of motion and you are solving the quadratic equation for this motion, then why not to solve it for the complete motion? In any way you have to solve the this quadratic equation. So this is the time of flight of this motion. Now in the next video we'll be bringing some more concepts of projectile motion. Thank you.